Hi, I'm Christian.
And I'm Vera.
And in this episode, we want to measure the piston protrusion on the Land Rover TDV6 2.7 liter engine.
Because we need to determine the head gasket thickness on each cylinder bank, right?
Exactly.
Very
and
right.
we do this based on a selection chart.
Using this tool after I complained so much that he actually built this one.
Because she didn't like this one.
Hope you enjoy the video.
Now, what we got to do today is to measure the piston protrusion in each cylinder bank so that we can calculate the gasket thickness.
Okay.
I made you here a sketch and you got to write down the numbers which we measure together. It's a two-man job because you need 3 to 4 hands.
It's always a two-man
Yes.
job.
And here I got the instruction for how we have to measure. So we have to measure each piston at 2 points in the horizontal per bank, 5 millimeter from the edge of the cylinder wall in. And once we got all the readings, we have to take per piston the average value and then select the highest value per bank and then select, according to this table, the gasket size. So let's do that together.
Okay, but I've got the worst wrench possibly.
Why are you complaining about my wrench? So this should be a 2-minute job. I think we're gonna be done.
Not a 3 minutes.
It's gonna be, oh yeah. Yeah, you use the wrench over here. And here, oh no, hang on. I gotta show my setup.
Oh my God.
So I found this block, which I made a couple decades ago. And I put a little dial indicator on here and I adjusted it so that when I'm on a flat surface, it hits 0. Don't you like
cheap
that?
Chinese piston protrusion gauge.
No. This is a Test German indicator. Except this indicator is not perfect for the job because when I have the needle in this angle, it's not measuring linear. Oh. So it may have a slight fault in accuracy. And
a slight fault?
Yeah, it's
we're talking here about hundreds and microns.
Okay.
There's no room for slight faults.
We start with the first piston here, this piston number 1, and we start on this edge, which is measurement point number 1.
Yeah.
Oh, see, this is not really good because I'm supposed to hold it over it like this, and now I gotta hold it like this.
Did you zero it out?
Yes.
Okay.
Okay, now go. Oh,
what?
That was too quick. Back. It was 0.558. 0.58. I gotta say, let's do the second one this way. Now you can read it yourself, see? I put it on like this.
So now you see, that is like the dumbest scale possible.
Well, it's perfect.
No, it's not. So it's 0.4, 0.5, so it's 0.62.
0.62?
Yeah.
I have the feeling if I push it on harder, I can get it to 0.61. Okay, let's do this side again if it measures accurately, if you can repeat your number.
So that's like the high point.
Yeah, 0.61. So. But we measured 0.58 in the last go round. So what do you think? Do you think those measurements are accurate?
I don't know. Well, I don't like the scale.
The scale?
Yeah. No, I don't think so.
It's supposed to sit on a flat piece of stock like this.
And it doesn't.
And it doesn't. So I think this is not optimal.
And I actually do not like that scale.
Because you have to add it up?
Because I have to add it up, yeah. You have to do some more work.
The problem is that when we do these numbers and we do them multiple times, they variate a little bit. Okay, I'll get a better indicator and I call you down when I'm done.
All right.
What do you think about it?
Doesn't look cheap Chinese.
No, this is German quality.
Doesn't say a name on it.
I made it.
Great.
Completely. See, I got this even slotted. Do you see this?
Slotted.
There, it's slotted.
But we need a big...
Can you please think about how you would slot something like this? This is a closed slot.
I don't know why you need it.
And also, do you see my surface finish?
Yeah.
Now we can repeat the measurement and you shouldn't be complaining anymore. Let's do it. Okay, 0. And you have to adjust it until the gauge is moving to the highest point. And 50, 59.
Yeah. Well, it was almost 60.
But it was 59.
It was 59.9.
Really? Do it again. Try to keep it on the highest spot. There, yeah, you're right. 59 point, that's the highest one, leave it.
Yeah, that's almost 60.
Still 0 on the reference table. Right? Good.
Yeah.
Write it here over that and cross it out.
I write it out under here.
Okay. How much was it?
Same.
60?
Same. No, 59.9.
Oh, hang on, there's dirt. Jesus.
1.9.
61.9, do it again. 61 point. Yeah, 61.7. Very well.
64.1. Oh.
You screwed up.
No.
0.56.
Yeah.
Okay, one more.
Yeah.
54.
Can't we turn the gauge around?
Yes, now I turn the gauge around. You didn't even honor my piece.
Yeah, it's very cool.
Okay, so now I turn the gauge around this way.
Yeah. So I can read and you can hold.
Yes. There we go. 0.
No.
Yeah. What?
Set it to 0.
It's at 0.
No, it's not.
You got
now it's at 0.
It's exactly the same.
No.
559.
Yeah.
Vera is claiming that she can read microns on a hundredths gauge.
So 601.
Why did you write this now here?
Oh, I'm sorry. Oh my God.
You screwed up completely.
Yeah. It's 579.
Oh, 579, she's right. Okay, you overruled by 30 years and 60 years of experience. Okay, then we have them all. Okay, now the values, oh, you got to do this up here too.
Yeah.
0.579. That's the value, okay. You need to circle the highest one. That's the highest one. 0.631, that's the highest one.
Yeah.
This is also cheap rig.
Can't you write cheap Chinese?
No, because it wasn't Chinese. It was just a cheap rig. And this one is the highest quality on planet rig. 0.631 in bank 2 is the result. That's correct. We have to select the correct gasket. So we calculated the largest value of squish found in one bank determines the gasket thickness. Also, the difference between maximum and minimum values of S in any of one bank should not be greater than 0.1. We have nothing greater than 0.1. And here, the biggest difference we have is 0.63 to 0.57. So this is a difference of 0.06. Now we select the gasket. In bank 1, we have 0.6. So we need a 0.591 to 0.640. So this would be a gasket number 2. And down here we select a gasket of 0.631.
It's the same.
No, that's it.
Now, the problem, he bought a gasket number 3.
The previous original gasket was a gasket number 3. Believe it or not, the gasket size from step 2 to step 3 by 0.05 millimeters. You have to just understand how much that is. Here, Achtung. My precision gauge reads 0 now, right? Look at that.
Yeah.
The steps in the gasket
Don't break it.
is this much. This is supposed to matter here. There's just no way in the world. We determined that we need a number 2 size gasket on bank 1 and bank 2. If you really like this video, go check out the other videos in this series. We started by taking the engine out. I think in the next video we did a line boring operation. Then we did, I think, a crankshaft install.
We definitely did a crankshaft install.
We did a piston install, and also take a look at our general repair videos about our Land Rover Discovery 3 and Land Rover Discovery 4. We call it Mall Crawler. So hopefully we'll see you here again on this channel, and
no, hopefully we see you next Sunday.
Thanks for watching.
Yeah. Stop recording. So my trailer is all empty, and I put the firewood over here. Now I'm gonna go and make lunch.